Scientific research and core samples from the cave enable us to better understand the Earth's history, both its distant and recent past. Most of the concreted formations developed after the last ice age, less than 10,000 years ago. Researchers have used carbon-14 dating to measure the growth rates of these formations. They're highly variable, from 2 millimeters to 10 centimeters per century. One can imagine how long it took for calcite deposits to create this spectacular stalagmite-covered floor.
Whenever a drop of water falls from the cave ceiling, it leaves a minute quantity of calcite on the ground. Imperceptibly, over the decades and centuries, these calcite deposits build up, forming stalagmites. Their shapes depend on many factors, such as the characteristics of the cave floor, the slope, and the height from which the drops of water fall. Every stalagmite is unique. Sometimes they stand alone, and often they have extraordinary shapes.
This barren landscape contains one of the most beautiful groups of stalagmites in the world. There's a vertical shaft in the Méjean Plateau at this spot. At the bottom, 75 meters down, the shaft opens onto an enormous cavity that holds a veritable forest.
The virgin forest, as it's called, is composed of 400 stalagmites. These stone trees have amazing shapes. Some of them reach 25 meters in height. Each formation is more incredible than the last. Arabesques, needles, palms, and graceful tapirs that look as if they're made of stacked ice cream cones. Stalagmites take on these complex shapes because the cave's water resources and the levels of calcium carbonate in the water vary.
The water droplets that form on the cave roof are, in fact, composed of rainwater that has filtered down from the surface. It picks up carbon dioxide in the topsoil, and as it seeps into the limestone bedrock, the carbon dioxide provokes a chemical reaction. It transforms the limestone into calcite, the raw material from which the decorative shapes in caves are made. They're called travertine formations. Thus, the growth of these beautiful formations depends enormously on the land, climate, and the vegetation on the surface.
If the ground is frozen, rainwater can't filter down through the fissures in the limestone. If there's not much vegetation on the surface, the seeping water will contain little carbon dioxide. Keeping these two principles in mind, it's easy to guess which European countries have the most numerous and the most elaborate cave formations. Yugoslavia, France, and Spain have temperate climates.
In places where the land is covered with prairies, scrub, and few trees, the rainwater filters slowly through the topsoil, which is composed of bits of rock and decomposing organic matter. It picks up large quantities of carbon dioxide along the way. Caves in these regions often have remarkable travertine deposits. On the other hand, in karstic regions with colder climates, like England, The limestone slabs have been literally planed smooth by glaciers, and because there's no vegetation on the surface, few caves here have formations, and they're often limited in shape.
After water filters through the limestone bedrock into an underground cavity, it collects in droplets on the ceiling, where it comes in contact with the cave's atmosphere. Chemically, the air in the cave is very much like air above ground. There's less carbon dioxide in the air than is dissolved in the suspended water droplets. This disequilibrium results in a reaction. The carbon dioxide in the droplets is diffused into the cave atmosphere. But this means the water is then too heavily loaded with dissolved calcium carbonate, and a calcite precipitate is formed. A minute ring of calcite is deposited on the ceiling around the droplet. And drop by drop, all these little rings build up and form these very fragile transparent tubes, sometimes called macaroni.